Why, how you doing? This is the fifth and final video for the June 2016 Algebra 2 Regents examination. It will cover problems 32 through 37, which is the remainder of the test. So without wasting any more time, let's get started. I love these short answer problems. Let's begin. Number 32 states, a house purchased 5 years ago for $100,000 was just sold for $135,000. Assuming exponential growth, okay, approximate the annual growth rate to the nearest percent, okay? So we can say our final amount, A of t, equals principal times 1 plus r raised to the t. This represents that growth, that exponential growth that they're speaking of, okay? So I'm going to have to plug in some numbers, but more importantly, they're asking me to approximate the annual growth rates. That's my R right here. I should have values that go in every other variable except the R, meaning, okay, it was purchased 5 years ago. That should be my time t. All right, it was purchased for $100,000. That was the principal it was purchased for. Okay, it was just sold 5 years later for $135,000. That's going to be the end amount after that 5 years of growth. So we're going to plug those values in, and we are going to see what growth rate we get to the nearest percent. So I sold it 5 years later for $135,000. That was my end amount. I initially bought it for $100,000. That is my principal, and I should put one more zero right there. All right. 1 plus r, that's what we're solving for. And that was over a course of 5 years. So that's my t. All right, so I'm just going to solve for r here. So let's go ahead and do this. The first thing I'm going to do is I'm going to start peeling things away from my r one at a time. And according to reverse PEMDAS here, opposite math, I'm going to get rid of this 100,000. I am not going to subtract. I am not adding 100,000. I'm actually multiplying 100,000. So the opposite of multiplication is division. Okay, bang, bang. I don't really encourage you to actually do the math out until the end. Let the calculator do it. Because if you get a decimal that goes on forever, you should wait, because you shouldn't round until the very end. Fortunate thing for us, I know if I divide this out, I actually get 1.35 exactly, and it ends there. So I'm going to use 1.35 equals 1 plus r raised to the fifth. Now, this isn't something that we commonly see, all right? And I just want to say one thing. I'm going to pull off to the side here and explain it this way, all right? If I have x squared equals 4, in order to get rid of my exponent, don't I just use a radical to the same root? So to get rid of a square, I use a square root. If this was a 3, wouldn't I use a cube root? All right, if this was an 8, wouldn't I use 8th root? Yes, they cancel. What I do to one side, I would have to do to the other. Okay, so now let's take a look at what we have here. 1.35 equals 1 plus r raised to the fifth. I want to get rid of that fifth power, so I apply a fifth root. What I do to one side, I have to do to the other. All right, so now my fifth power and my fifth root cancel. Let's move this over here. I have the fifth root of 1.35, which I know is going to give me some long run-on number, so I'm just going to leave it like that for now, equals 1 plus r. Well, the last thing to get my r alone would be to subtract 1 from both sides. Let me scroll down here to give us a little bit more room. So I have the fifth root of 1.35 minus 1 equals my r. This I'm going to put in the calculator just like that. So let's bring up our calculator. Let's turn this bad boy on. Come on, where are you? And in case you didn't know, all right, under the math menu, number 5, if I wanted a cubed root, I would pick number 4. That's the root. But if I wanted a root bigger than 3, I pick choice 5 here. Okay, what does that tell me? This x means I can put anything there. So I hit enter. Now the calculator by default is putting the last answer I had right up here. So I'm going to go back there, and I'm going to change this right to a 5. I want the fifth root of 1.35. Now, don't put your -1 here. You don't want that under the radical, all right? So make sure when you're in this situation, it's telling you, pop out, bam, -1. I hit enter, and this is what I get, this fine answer right here. They want this to the nearest percent, okay? So I got to come back here and take a look at this and say, in order to change this decimal into percent, I slide the decimal over 2 times. So that gives me approximately 6.18587.5, etc. percent. But they want it to the nearest percent, which means the nearest whole number. That will stay 6 because the number after it is smaller than 5. So your growth rate for a house that you bought at $100,000 and sold 5 years later for $135,000 should be approximately 6% growth rate. Not too bad. I think, number one, most importantly, you got to remember growth and decay formula, okay? And next, you got to know how to handle this power of 5. If you can do that, this becomes really, really easy, okay? So our answer was 6%. All right, we are now crossing over to part 3. This is the second short answer response portion of the test. And you'll notice that these are not worth 2 points anymore, so they step them up a little bit. They are now worth 4 credits each, okay? Answer all 4 questions, and please do that. Don't leave anything blank or put I don't know, or don't just rewrite the numbers they give you in the equation. Try and do some math, some relevant math. Try and get some points if you can, okay? Each correct answer will receive 4 credits. Clearly indicate the necessary steps, include appropriate formula substitutions, diagrams, graphs, charts, etc. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. For all questions on this part, a correct answer, okay, numerical answer with no work will receive 1 credit. Now, for part 2, they were out of 2 points. That same situation would give you 1 out of your 2 points. It gives you half credit. These are worth 4. So maybe, oh, will I get 2? Will I still get half credit? No. You will always get 1 point out of the 4 if you can come up with the right answer without doing any work. If you do it all in the calculator, and you're supposed to do it algebraically, and you just put the answer you get in the calculator without showing any work, you always get 1 point, okay? Even if it was a 6-point question, you would get 1 point, all right? So all answers should be done in pen, except for graphs and drawings, which should be done in pencil. I can't tell you the number of kids that forget to do that in pencil. I mean, I think they still grade them in my experience, but technically if someone at the state had a bug up their little bum and just wanted to make people's lives miserable, they could look at that and give you a ration of poo-poo. Let's move forward. Oh, it looks like we have a systems of equations problem here. All right. Solve the system of equations shown below algebraically. And this is algebra 2, so they tend to put a circle and a straight line, okay? I should recognize that this is a circle, this is a straight line. So if I have a circle, okay, and I have a straight line, I can get 1 answer. Maybe they touch just 1 time. Maybe they touch right here once, okay? I don't know, maybe they touch twice. You know, maybe it's a situation like this, where not only would they touch here, but obviously they would touch here, all right? Or maybe they don't touch at all. So we're going to have to prove this algebraically, all right? So, let's start. I'm going to do this as I do most circles and lines using substitution, all right? I'm going to take my line equation, and I'm going to solve it for either x or y, all right? And what do I mean by that? I'm going to take 2x plus 2y equals 10, and I'm going to set this equal to one of my variables, all right? I'm going to have like either x equals whatever by itself, the x, or y equals whatever. X is far left. You could use either one. I'm just going to happen to get rid of the y, minus 2y, minus 2y. So I have 2x equals 10 minus 2y. Okay, now if I divide everything by 2, I have x equals 5 minus y, okay? Because 10 divided by 2 is 5. And if I take 2y and divide it by 2, my 2's cancel, and I just end up with my y. This is important for 2 reasons, okay? Number 1, I can now do substitution. What does that mean? For my second equation here, wherever I see an x, okay? Wherever I see an x, I happen to see one right here, I can put 5 minus y in for that x. And now that entire equation only has y's. It only has one variable, and I could solve for that one variable. All right, that's the whole purpose behind substitution. And next, after I solve for y, I need an x for that y. I'm also going to come back here, and that's how I'm going to get my x when I figure out what my y is. So let's start first by solving for y. All right. I'm going to rewrite this equation. I'm going to say x minus 3 squared plus y plus 2 squared equals 16. In for this x, I'm going to put 5 minus y. I'm going to substitute it in. So I've got 5 minus y, goes in for the x. I still have a minus 3 afterward. That's all squared. Plus y plus 2 squared equals 16. Now, I have a lot of students who see this and recognize and say, I need to start foiling here. And you do, okay? So this still equals 16. I'm going to FOIL this one first. I know that should be y squared plus 4y plus 4, okay? And I have this plus out in front. Now, I see students that take this 5 minus y minus 3 and try and FOIL it with 3 terms. Don't do that. Don't do that at all. Let's combine like terms first. So I'm going to take this little bugger out here, and I'm going to show you what I'm going to do with it, okay? I'm going to take this little bugger right here. I'm going to show you what I'm going to do with it. I currently have 5 minus y minus 3 squared. I'm going to combine these two numbers. 5 minus 3 is 2, so now I have 2 minus y squared. Now I can FOIL that. That's a much easier problem to FOIL. 4 minus 4y plus y squared. That's what I get. That is going to go right here. So I have 4 minus 4y plus y squared. All right? That's exactly what I can get. And you'll notice this is going to be nice when we're all said and done. And let's start combining like terms. And we obviously have a quadratic, what's going to be left. And I'm going to bring everything over to one side and solve. And I'm probably going to get 2 answers for y. Meaning, I'm going to have a circle with a line, and I'm going to have 2 answers, okay? I'm going to need 2 sets of coordinates, an x and a y and an x and a y. Based on what I have right here in this equation, I'm probably going to find 2 y's. I'll have to go back and get both x's, all right? So let's combine what I can. I have 1y squared and 1y squared. That gives me 2y squared. This is nice. I have negative 4y and positive 4y. They just cancel. Bye-bye. Nice. All right. Now I have a positive 4 here and a positive 4 here. That gives me positive 8 equals 16. Now, there's 2 ways I can proceed from here, and neither one is wrong. I can bring my 16 over, and I can try and factor. I can bring the 8 over because I'm now just solving for 1y, so I can just use opposite math. Okay? I can even divide everything by 2 to start, which is what I might end up doing. Okay? But first, let's do this. If I were to have a situation, this has nothing to do with the problem, I'm just going to point out to you. If I had x squared plus 2x, okay, plus 1 equals 0, I have to factor this because I have an x squared and an x. I cannot combine them to make one term. Okay? I can't have just one variable to solve. I have an x squared and an x. But if I had x squared minus 4 equals 0, I can definitely move the 4 over and use opposite math because I only have one term with an x. That's what I'm going to do here. I have one term that has a y. Yes, you can bring it over and use a difference of perfect squares and factor and booty cheek and T-bone. You can do that. I'm not going to here, okay? I'm just going to subtract 8 from both sides. Bam! I've got 2y squared equals 8. Now I'm going to divide by 2. And I've got y squared equals 4. Oh, this is turning out nice and easy. All right. Now, last thing I need to do here. Please do not say y equals 2. Don't forget, it is plus and minus 2. How come? I can take, when I have y squared equals 4, of course I can put a 2 there and get 4. I can also square a negative 2 and get 4. A positive 2 times a positive 2 is 4. A negative 2 times negative 2 is also 4. So I have 2 answers, okay? But I'm not done. Because when they want the solution to a system, they are looking for a coordinate, a point. In this case, you're going to have 2 points. So right now, I have y equals negative 2, and I have y equals positive 2. So how do I solve for the x? So I know x equals 5 minus y. I'm going to absolutely use that. I mean, some people say, oh, come back here, and I'm going to plug it. They say, keep on going higher, higher. They say, I'm going to, Mr. Visca, I know that if if y is positive negative 2, I'm going to put it in here and solve for that, and you can. You will get the right answer. But if you're solving for x and you need to get x alone, just use this. It's set in stone, and that's exactly what I'm going to do. Okay, if x equals 5 minus y, and y is negative 2, x equals 5 minus negative 2. That means x would equal 7. So one of my coordinates, when x is 7, y is negative 2. I'm going to do the same thing with positive 2. If x equals 5 minus y, that's 5 minus, this time my y is positive 2. 5 minus 2 is 3. So my second coordinate is 3. X, y is 2. You need coordinates, okay? When they ask you for a solution to systems, they're asking you for coordinates. So there it is in all of its glory. Systems tend to be a lot of work. It's a lot of algebra work. There's factoring, there's combining like terms, okay? There's maybe booty cheek and T-bone maybe, definitely substitution back in, but it is a lot of simple algebraic work. Okay, you just need to look at these problems and say, I know what I got to do. Probably going to take a little bit more writing than other problems will, but I know how to do it, and I'm just going to do it and get it done and get these 4 points and move on. Okay? All right, number 34. Alexa earns $33,000 her first year of teaching and earns a 4% increase in each successive year. Write a geometric series formula, S of n, for Alexa's total earnings over n years. And then it asks us the second part. Use this formula to find Alexa's total earnings for her first 15 years of teaching to the nearest cent. Look it. Geometric series formula, S of n. That is actually on your reference sheet. If you ever see that, you go right to your reference sheet. Bam, that would be your reference. Let's see again. Mode, rectangular. Oh my goodness, it worked. Let's do this. Bang. Right. So we are going to write a geometric series formula, S of n, for Alexa's total earnings over n years. All right? Here we go. Here's our equation, geometric series, and it specifically says S of n with a geometric series. And I know this is on the reference sheet, okay? So you need to... All right, you need to go for that one and work with it. It's a given, which is beautiful. So here's our problem. We need to figure out what goes in for what variable. I know S of n, according to the reference sheet, equals A1 minus A1 times R raised to the n. Okay, it's just my R that's raised to the n. All over 1 minus R. So what does A1 represent? A1 represents your initial starting value. That's A1. That's going to go in 2 spots. Okay? Which is confusing, they call this R. Your R is not just 4% or 0.04. Your R is the same thing as your B. What do I mean B? A, B to the X. it's 1 plus your R. Okay, so when they refer to R, they're really telling you 1 plus your R. If our rate is 4%, it's 1 plus 0.04. Therefore, your R equals 1.04. It's not just 0.04. And this sometimes throws people off, but that's the case for this geometric series. So S of n is going to equal 33,000 minus 33,000 again times 1.04 to the n all over 1 minus 1.04. This is a geometric series formula to figure out Alexis' total earnings. Now, once you get that, look, if you understood that this was on the reference sheet and you understood what R was, this is very simple. In fact, the next part is even easier. This is a gift of 4 points if you know where to find this. Okay? So they're saying use this formula to find Alexis' total earnings for her first 15 years. That means that's what your n is going to equal, 15. So on S of 15, it's 33,000 minus 33,000 times 1.04 to the power of 15, all over 1 minus 1.04. And all you have to do is put that in the calculator. That's how simple that is. Okay? Because I like to use the fraction feature here, I'm going to say alpha y equals enter. And I'm going to put 33,000. Okay? And I'm going to subtract 33,000 times 1.04 raised to the 15, all over 1 minus 1.04. That looks pretty much perfect to what I need it to look like. I hit enter. And they want this to the nearest cent. Okay? So when I write my final answer out, I'm going to write 6,60778 point. That will stay a 9 because the number after it is smaller than 5. There's your answer right there. That was so simple if you knew where to find it. Okay? Good one. Number 35 is a data and stats problem, and this actually came off our very last lesson. This was one of the problems that we did. Unit 5, Lesson 6, I believe. Anyways, 55 students attending the prom were randomly selected to participate in a survey about the music choice at prom. 60% responded that a DJ would be preferred over a band. Members of the prom committee thought that a vote of 50% for the DJ and 50% for the band might happen, okay, that this would happen. Now, the 55 students they asked, that wasn't everybody. They just took a sample, and 60% preferred a DJ. And then they thought, well, if we ask everybody, not just these 55, we might get a 50-50 split. So what they do is this. They run a simulation 200 times. Each one of those 200 simulations, they make the situation where they take a sample size of 55 students, just like they actually did, based on the premise that 60% of the students would prefer a DJ. The approximate normal simulation results are shown below. This question gives you so much information, but it's really easy, okay? And you really don't need all this. So normal simulation, it's like a normal bell curve, kind of like that. Kind of it looks like that. The most important part that we need is right here. Please make sure you check everything out. Because if I look down here, look what the first thing, there's actually two questions. Look what the first one asks. Using the results of the simulation, determine a plausible interval containing the middle 95%. In my classes, that's the moneymaker, 95%. 95% represents an interval that is the mean plus and minus 2 standard deviations. Okay? I could write 2, that also means standard deviation, so I could say mean plus or minus. Either way, it's fine. That's not a 0. That's a 0 with like a little pigtail on top. Okay? Either way, I typically write it like this. Okay? I know the mean. Here's the mean. Here's a standard deviation. All right, so let's figure out that 95% interval. Okay, that's the mean, which is 0.602. I need to add and subtract 2 times the standard deviation, which is 0.066. Okay, and I'm going to, again, use the calculator for this because why not? I have one for every single question. I'm going to go here. I am going to clear this out. I'm going to say what is that? 0.602. 0.602 plus 2 times 0.066. Now, I don't have a plus or minus button, so I'm going to have to add it. Then I'm also going to have to subtract it. 0.734. Okay, that's my upper limit, or my upper bound of the interval. I'm going to come up here, hit enter, and I'm just going to change this to a minus, because now I need to subtract that. Not a negative sign, a minus. Okay, and it's 0.47. Now, my plausible interval, if you write this from 0.47 to 0.734, how come you will get that wrong? Well, because of Mr. Visca's excitement of showing you that this was actually the moneymaker, I didn't finish reading that problem. Okay, it says round all values to the nearest hundredth. Hundredth is 2 decimal places. This 3 will stay a 3 and not round up. So your answer better not include that 4, the thousandths place, only the hundredths place. Okay, simple. If you knew what you were doing and what you were looking for, this is real easy. Now the next problem, the next question says, members of the prom committee are concerned that a vote of all students may produce a 50-50 split. Explain what statistical evidence support this concern. Look it. 50-50 split means 0.50 would be the outcome, right? This moneymaker, and I mentioned this in the notes from Unit 5, Lesson 6, is all the really valid possible outcomes. Isn't 0.50 within this range? It is. If I had a number line, okay, 0.47 to 0.73, and within this number line are all the really, really good chances of the outcomes happening, 0.50 is absolutely 100% within that interval. And that's exactly how I state it, okay? It says explain. So 0.50%, or excuse me, 0.50 or 50% is within, I was going to start to write the next, is within, and I'm going to use their words, plausible interval, okay, is within our plausible interval. So it can happen. Okay? So they say, well, it says to use statistical evidence. You're using your plausible interval from step 1 here. That's your statistical evidence. And this right here is your answer. You don't need the number line. The number line I just put up to kind of give you a visual. This that I just circled is your answer. So why is this concern a valid concern? Because the 0.50 is within our plausible interval. 0.50 is one of the many possible or plausible outcomes that can happen. Now, if they said it's 0.30 possibility, that's way out here. You should say, no, that's not one of the likely outcomes. That doesn't really have a good shot of happening at all. But 0.50 does. It's right here. Number 36, which function below has a greater average rate of change from -2 to 4? Justify your answer. Justification means show your work. Show all work. Saw, baby. Show all work. I'm going to start with f of x. We have a function f of x, and we have a function g of x. So which one has a greater rate of change? Rate of change means slope. Man, in calculus, that's all we talk about, rate of change, slope. Okay? So you should know rate of change really means slope. And slope, that means slope. And slope is really change in y over change in x. This, to me, is a really easy question. Again, these 4-point questions weren't that difficult. All right? So if I want this from when x is -2 to when x is 4. Here's when x is -2. Here's when x is 4. let's do a change in y over change in x. Okay, so let's do this down here. Change in y over change in x would be from 80, okay, to 1.25. So 80 minus 1.25 all over 4 minus a negative 2, because that's my change in x. All right. Again, my change in y are the y values, the difference, and the change in x are the difference in the x values at these coordinates. All right, let's put that in the calculator. Why not? We can. Let's turn this on. And I'm going to use my alpha y equals function because I love the fraction function. 80 minus 1.25. All right, I'm going to put that over 4 minus a negative 2. I know that should be 6, but I'm still going to hit that out. I get 13.125. Okay, 13.125. So here we go. So that is 13.125. Now, I need to do the same thing for g of x and see which one is a bigger or greater average rate of change. I don't have a table for g of x, but I can make one. All right, so I'm going to use my calculator to figure this out. I know my x's. I got to use a change in y over a change in x. All right, so how do I figure out? I know my x is from 4 minus, so from 4 to negative 2. So I got to figure out what's my function with a 4 in it, whatever that is, that's my y, and subtract my function with a negative 2 in it. Let's do this. Let's go to y equals. And let's put, I'm actually going to make the table in the calculator and just do the substitution. So I've got 4x cubed minus 5x squared plus 3. And I'm going to look at my table. And I want to know from negative 2 to 4. Ooh, look at that. So I'm going to pull this right out here. And I'm going to use this. All right. So what is g of 4? G of 4, when x is 4, I get 179 as my y. So this, 179 minus. What about g of negative 2? Negative 49. So negative 49 all over 4 minus negative 2. Let's put that in the calculator and see what we get. I'm going to go back up here and hit enter and just change the top. Go up. 179 minus, in parentheses, negative 49, parentheses. What is 38? That is 38, children. So I go down here and I say 38. All right, well, we got to answer the question. Which function has a greater average rate of change? G of x has a, and I'm going to answer this exactly, greater rate of change. There it is, because 38 is bigger than 13.125. You find the slopes. You find the slopes of each one and figure out what number's bigger. That is Algebra 1 type stuff. Okay, probably Math 7 or Math 8. All right? On to the next one, part 4. This one, same deal. 6 credits, okay? Necessary steps, utilize information, yada, yada. Correct numerical answer with no work will receive 1 point. You will not get half of the credits. You will get 1 out of the 6 points. That is better than 0, but not as good as 4 or 5 out of 6. Not even as good as 6 out of 6 is what we should strive to get, okay? So, let's start this bad boy. All right. Drugs, oh my goodness, break down in the human body at different rates, and therefore must be prescribed by doctors carefully to prevent complications such as overdosing. The breakdown of a drug is represented by the function n of t equals n sub 0 e, all raised to the negative rt, where n of t is the amount left in the body, n sub 0 is the initial dosage, r is the decay rate, and t is the time in hours. All these variables that we just read in this equation that make us say, oh my God, they give to us. Amount left in the body, N of 0 is the initial dosage. R is the decay rate, and T is time in hours. Okay. Patient A is given 800 milligrams of a drug with a decay rate of 0.347. Patient B is given 400 milligrams of another drug with a decay rate of 0.231. Write two functions, A of T and B of T, to represent the breakdown of the respective drugs given to each patient. All right, so I'm going to start, and A of T is going to be my first equation. Patient A, 800 milligrams to start with a decay rate of 0.347. That is really all we need to know. So A of T equals, okay, my initial dosage, which is 800 milligrams this patient is given, E to the negative R. My decay rate is 0.347 raised, okay, that's times T. That's it, okay? And for patient B, which I'm going to call B of T, they were given 400 milligrams to start, and the decay rate of 0.231. So B of T is going to be 400 E to the negative 0.231 times T. That's it. We're done with part A. I guess the first part, they're not A, B, C, or D. Now next, I mean, they want us to graph these two. So, I mean, can I move these down here? No. Let's do it this way. Graph each function. Bam. I'm going to graph these, and it's really simple. This starts at 800. So my output has to be at least 800. So I'm going to make my y's go to 1,000. And I'll just make my x's, or in this case, the x-axis is labeled t for time. I'm just going to have that go to 10. All right? And we will get a good, let's clear that out. So the first one is A of t. I'm going to do 800. I'm going to do E raised to the negative 0.347x. Okay? Number two, I'm going to do B of t now. It's 400. Second, oh my goodness gracious, e to the x, point, it's negative 0.231x. I'm going to make my window. I know this is going to start at 800 as a starting point. So I'm going to go a little bit higher than 800. Let's go to my y value. It'll start at 0 and go up to 1,000. Now my x's, that's time. It starts at 0. I'm going to make it go to 10. I'm going to graph these two. That's my B value. That's my A value. And if A value is going to cross and get above it here. So let's do this. Let's look at our table. Starting at 0. Okay, and eventually we're going to have to go, we're going to plot these. Okay, I'm going to go back here. And I'm going to go down from 6. Continue. Ooh. There you go. All right. So I don't have to go back and forth. This is my A. And this is B. Patient A and patient B. All right. I have 0 on the bottom here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So every 2 is going to be 100. Okay, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. All right, and now T is time, and it just says different rates, breakdown. T is time in hours. So I don't know, I'll just go every 2 would be an hour, right? So 1 hour, 2 hours, 3 hours, 4, 5, 6, 7, 8, 9, 10. All right, let's graph them both. And let's start with A. Okay, so I'm going to start with this column here. At 0, I'm at 800, right at 800. Okay, at 1, I'm at 565. So I'm just going to ballpark this. I don't know, in between 500 and 600, slightly above 550. Okay. At 2, I'm just at about 400. So we'll go right about there. Okay, and we're just going to keep on going down this. 282 at 3, that's closer to 300. 282. 4 is just about 200 right here. 5 is 141, so that's a little bit below 150. 6 is at about 100. That's good. Okay, 7 is at 70. It's about here. 8 is 50. It's about here. 9 is 35. What about here? 10 is about 25, which is about here. So this is A. Okay, sorry, I'm trying to graph this as good as I can. This should be done in pencil on your test. Boom. This is, I'll put an arrowhead, A of T. Let's do B, this column. Okay, starts at 400. Then it goes to 317. Okay, I'm just going to go down the line here. 317, which is about right here. Then it goes to 250, a smidge above 250 right here. Then at 200, at 3, which is right here. At 4 was 158. Sorry that you got to hear me say these numbers. 5 is at 126. 6 is at 100. That is almost perfectly itself. 7 is 80. Gets slightly above now. Okay, 8 is 63. That's slightly above. 9 is 50. That is definitely above. And 10 is 40. Okay, oops, that's right here. So now, you know they're going to say something about where they cross at some point. Okay, blue is B of T. Okay, beautiful. Now, to the nearest tenth of an hour, when does the amount given drug remaining, okay, when does the amount of the given drug remaining in B begin to exceed A? So when, okay, B is the blue one. It's less than A. It's less than A because it's below it, less than A. Then it hits right here and begins to be above it. So they're asking at what point does that switch? I'm going to do that right in the calculator. It doesn't say to do that algebraically. So if I go to graph here, I just want the intersection. We know it's close to 6. All right, 1, 2, 3, 4, 5, 6. It's going to be close to here. So I hit second, calc in blue, which is a trace button. And I went to the intersection, which is 5. And I just hit enter 3 times. 1, 2, 3. And that happens at 5.97. So they say to the nearest hour, 5.9, if I round that up, that's my hour, is going to be 6. I'm going to call that 6 hours. All right? And last but not least, they say the doctor will allow patient A to take another 800 once the drug is about 15% remaining. Okay? So I know patient A is 800 times e to the negative 0.347 t. They want to know what time to the 10th of an hour will he have 15% remaining. Well, first of all, what is 15% of 800? I multiply 800 times 0.15. Again, let's use our calculator. 800 times 0.15. That's 120. So they're basically saying 15% of 800 is 120. When there's 120 remaining, what time would that be where this guy can take another dosage? All right, let's figure this out algebraically. The first thing I'm going to do is opposite math. Divide by 800. Divide by 800. This, I'm going to do you a solid, that's 0.15, equals e to the negative 0.347 t. If only there was a way to get rid of my e. Friends, natural log and e cancel. Boom. So I'm going to take the natural log of both sides. So the ln of 0.15 equals negative 0.347 t. I'm down to one final step. Divide both sides by negative 0.347. Gone, gone. Divide by negative 0.347. So t is approximately, love that calculator, I take the ln of 0.15 and I divide that by negative 0.347. 5.46, they want that to the nearest tenth, which means that 4 will round up to a 5. 5.5 hours. Thank you very much, and I will see you for the next video, which will probably be the August 2016 exam. Peace out.